This is a recent running analysis performed at the Performance Lab clinic. There are a number of biomechanical faults occurring, but we'll start off with looking at this runner's position of his hip and his pelvis. As you can see, when he initially makes foot contact on his right leg, his pelvis remains level. If we go on to measure the angle formed between his pelvis and the centre of his hip through to the centre of his leg, this angle is 86 degrees. If we continue to see what occurs as he continues to weight bear through his right leg, we can see that there's a significant drop of his pelvis to the left hand side. And again, if we go on to measure this angle, this has significantly reduced down to 76 degrees. This is known as a Trendelenburg drop, and it significantly increases the load going through the lumbar spine and the pelvis. If we also look at what is occurring as a result of this hip drop, there's a significant curvature which is occurring into his lumbar spine as a compensation. This will increase the load through his lumbar spine and his pelvis and also make him a less efficient runner. If we also look at the position of his foot during takeoff, on his left hand side we have a straight position of the foot, and then if we run the video through looking at the position of his right foot, we can see that the angle has changed as his foot turns out and his lower leg externally rotates. In addition to this, we also have some significant retraction at the left shoulder, which we can see occurring here compared to his right side. So if we run that through, we can see as the left shoulder retracts compared to the right. This is likely to be as a result of trying to gain stability for the right hip, as the body uses this particular sling from the left hand side shoulder down to the right hip. There are other multiple mechanical faults which are occurring both at his calf and his knees, but this may be discussed at another time. If you would like to have your running style analysed by one of our experts at the Performance Lab, follow the link below.